Money. Love it or loathe it, everyone needs it, and it's harder to save than Uncle Ben. Now, depending on where you live, you may not have this issue, but many power companies charge variable rates based on time of use. This is not a new thing. It's been around and fairly common since the 1970s. There may even be a few people watching that remember why. Imposing higher rates at peak usage times is meant to discourage abuse of and strain on the largest machine in the world, the United States power grid. So, what's the best way to absolutely ensure you're limiting use during those times? Load shedding. You may have heard of this before, especially if you watched the previous video. It's a popular thing for people with solar panels to do in order to stay within their system's rating, net zero meter, or just to extend their time on battery during an outage. I already showed how to set up some basic load shedding in my last video using actions, webhooks, and a basic Shelly script. The goal was to limit power usage by sequentially disabling and enabling a list of prioritized devices. In this video, I'm going to show you how to set up advanced load shedding and monitoring. There will be 3 sections in this video. The first section will be varying configuration, range, timing, priority, and so on, based on a schedule using an already prepared Shelly script. The second section will be on setting up notifications using web requests in the same script. The last section will be on adding remote monitoring for systems with multiple energy metering devices. Whether you've got a solar setup, generator, or nothing of the sort, but you're keen on keeping your money, carefully controlling your power requirements based on a schedule can be very handy. Luckily, it's almost as easy as the basic load shedding since Shelly has been kind enough to write the code for us. I'll be using my trusty Shelly Pro 3 EM for this demonstration, as well as several more of the Shelly Pro devices that were used in the basic load shedding video. You can use nearly any power metering device from Gen 2 and up, with a few exceptions. I'll leave a list of scripting-capable devices in the description. To begin setting up advanced load shedding, first access your device in whatever your usual way is, be it Web UI, the Shelly app, or telepathy. Now click on, tap on, or think real hard about the script button on the left. Then, Library, and find the Advanced Load Shedding script. Import the script, and now you're ready to start configuring. Just like the basic script, here you can set your maximum before shedding, minimum before loading, and the polling and cooldown times. But in this script, the values you put here will only be used if there isn't a value set in these schedules further down. I'll get there in a moment. Then you have the option to turn logging on, which will output certain events to the device console. KVS status sets whether or not to store status information in the key value storage, which is under Advanced on the left side of the Web UI, and I don't think available on the app as of this recording. The next 3 variables are obviously for simulation. If you want to test something, you can alter these values, but be aware that it will not send toggle commands while one or more of the simulation variables are set. Now we come to the device list. This device configuration is slightly different than the basic load shedding script. Just like the basic script, you set the device name, which is used to reference the device further on, and you can choose between using the APC or RPC call, depending on the generation, or you can use the address generation, device type, and circuit ID. You can also provide a description for use in logging or some custom function. If you don't know what your device type or generation is, you can look through all of the Shelly devices and their specs on the Shelly knowledge base, which I'll link to in the description. Unlike the basic script, you can set the notify flag, which does exactly what it sounds like it does. It turns on notifications for a specific device or circuit. Next, there's configuration for the actual notifications, which we're skipping until the next video segment. That brings us to schedules. For schedules, you can specify a name, whether or not you want to use the schedule, a start time, what days the schedule applies to, a description, and a priority order for this time frame. You can also override minimum, maximum, polling time, cooldown time, and you can set a notification by name to be fired for on or off events. Some notes about schedule properties. Start time is 24-hour time. There is no end time because the end time is just the next schedule's start time. The days property must always remain the same length, 7 characters, and if you want to exclude a day, replace the uppercase letter with a period, as shown here. Also, the priority list does not need to include all of the devices in the device list. There are also on and off properties that allow you to set the state of specific circuits or all circuits when a schedule becomes active. That's it. Now you can run different configurations at different times and hopefully save yourself a bit of time or money in doing so. Now, let's go back and take a look at the notification configuration. You set a name which you can reference the notification with, and you can set an optional description. You must specify a URL to send the requests to. You can send GET or POST requests, simply include or omit the POST property. Here is the script already configured on my 3EM. I have created this Flask API with SQLite in Python to send data to. The API accepts key value pairs to store and can retrieve one or all of them. I'll put a link to the demo Flask API in the description as well, if you want to do this sort of thing. In order to get information that changes into the request, you can use the following terms in curly brackets inside the URL, post, or both, and the script will replace them with their respective values. Here is some information that accumulated when I ran this script earlier. Now let's take a look at using another energy meter to send data to this one. Access your additional metering device your usual way, Web UI, Shelly app, or Seance. Tap on, click on, or feel the forces of the great beyond guide your hands to the scripts section. Once there, select or summon from the abyss the script library. Look for Add Additional Meter to the Advanced Load Shedding script and import it. This script seems to work only for the 3EM at the moment, but I believe it will be updated to work with others in the near future. If not, I'll make a version that does and share it later. The settings here are few, so this will be fairly quick. While I have your attention for a moment, though, I'd like to invite you to tap on, click on, or conjure paranormal forces to strike swiftly the like button. You may also want to subscribe to the channel, and if you're not clairvoyant or at least moderately clever, use the bell to receive notifications when I post a video. I know you'll absolutely pay attention to those. Going back to our script. Just like the other script, you can adjust polling time. You have to point this script to the address of the device running the advanced script we just set up and give it a max and min factor. These are used with the average draw to create a range for this device's output that is later used in the total power calculations on the main device. I'm not entirely certain why, but I believe it has to do with smoothing the curve so using multiple devices doesn't amplify jitter in the total value. Next, you must specify which schedule you would like to apply this metering script to. You could feasibly use more than one of these scripts to affect different schedules. Lastly, you can test the script like the others using the simulation power property. That's it. Now you can use more metering devices in more complex arrangements. I hope this was clear and informative. Do let me know so in the comments. Before I go, I want to thank these fine individuals for helping keep the lights on. I appreciate their support as well as every subscriber or viewer. Thank you all for giving me some of your minutes, and I do hope you'll join me for future videos as I continue exploring smarter circuits.